Hi Lakewood 7th graders, this is Miss V, and this is your third video in our series on quarter 2 week 3, and in this video we're talking about solving one-step equations with rational numbers. So I'm going to use the skills that I learned in the previous two videos to actually solve one-step equations. One-step equations are where there is simply one step in between me and the answer. So if you look at this first equation, I'm multiplying x times 3 here, and I'm saying that equals 21. So there's some number that I could substitute for x right here that would give me a 21 right there. And kind of intuitively, some of you may see that that's 7, but we don't always see those things intuitively. So in order to undo this multiplication, I'm going to use the inverse operation of division, and I'm going to divide both sides of my equation by 3. Now I have to do that on both sides to keep my equation in balance. On the left side, 3 divided by 3 is 1, so I'm simply left with 1 times x, and that's what I wanted. On the right side of the equation, I'm left with 21 divided by 3, which is 7. And kind of intuitively, we knew that our answer was going to be 7. But I want you to notice what I'm doing here. I'm dividing a positive number by a positive number. And in our earlier video, we said when the signs are the same, you're going to always get a positive number. Let's see how that plays out with negative numbers. So here I'm multiplying some number times negative 3, and I'm getting a positive 21. So again, I'm going to do the inverse operation and divide by negative 3. Negative 3 divided by negative 3 gives me 1x, and that's what I was looking for. And then I need to do the same thing on the other side of the equation. So 21 divided by negative 3 is, well, we know it's 7. And then because the signs are different, we're going to give it the sign, give it a negative sign. Let's do 3x equals negative 21 and see how that sorts out. I'm dividing both sides by 3, the inverse operation of multiplying by 3. I get 1x right there, and negative 21 divided by 3 is negative 7. Notice the signs are different, so I'm going to give it a negative sign. And in the last example on the right, I have negative 3x equals negative 21. Again, I'm going to use my inverse operation. Negative 3 divided by negative 3 gives me 1x. And negative 21 divided by negative 3 gives me a positive 7. Notice my signs are the same. And whenever our signs are the same, it's going to be a positive number. So let's see how that sorts out when we have fractions. Notice right here, I have some number, and when I take half of that number, I get 5. And we might intuitively think, oh, that number is going to be 10, because I know half of 10 is 5. But again, sometimes it's not quite so intuitive, so I'm going to use the inverse operation of multiplying by 1/2. And I'm going to divide by 1/2, which is the same as multiplying by 2. Notice 2 times 1/2 is 1, and that's what I wanted, is a 1x right there. So again, whatever I do to one side of the equation, I must do to the other to keep my equation in balance. And so I multiply 5 times 2 and get 10 over 1. And so my answer right here is x is equal to 10. And that's kind of what we thought we were going to get. Notice in this second problem, the only thing that is different is I am multiplying x times a negative 1/2. So the inverse operation would be to multiply both sides of this equation by negative 2. I'm getting kind of squished up there. To multiply both sides of the equation by negative 2. So I have to do that to this side of the equation as well. And I end up getting 1x here, which is what I was after. And on this side, I end up getting 10, but this time it's a negative 10 because I'm multiplying 5 times negative 2. If I look at the next problem, let me make a line here because I'm getting kind of squished up. I'm going to have to multiply both sides times positive 2. The inverse of multiplying by 1/2 is to multiply by positive 2. And when I multiply both sides by positive 2, I get x on the left and negative 10 on the right. Remember, a negative times a positive, the signs are different, so my answer is going to be negative. And finally, I have negative 1/2 x equals negative 5. I'm going to do the inverse operation and multiply by negative 2 over 1. And since I'm multiplying a negative times a negative, we know when those signs are the same, my answer is going to be positive. So in this case, I'm going to end up getting positive 10. So in every one of these situations, in order to do the inverse operation, I had to use division here because I was multiplying. And I had to use multiplication here because I was dividing. But sometimes we have one-step equations where, in order to do the inverse, we use addition and subtraction. Take a look at this first equation. I'm taking x and I'm adding 3 to it. So there's some number x that when I add 3, I get 17. And again, many of us may intuitively see that that should be 14 because 14 plus 13 is equal to 17. But if I don't see that intuitively, I can always use the inverse operation and subtract 3 from both sides and get x equals 14. And that's what I was expecting to see because I intuitively knew that 14, sorry about the dog, you guys, 14 plus 3 is 17. So let's see how that works when we have positive and negative numbers that we need to take into consideration. Here, the inverse of subtracting 3 is going to be to add 3. And so if I add 3 to both sides, I end up with x is equal to 20. In this situation, I'm going to subtract 3 just like I did up above. But notice when I subtract 3, I'm now subtracting 3 from a negative number. So if you wanted to, you could make your number line and you could go out here to negative 17 and then count down 3 units and see that you were at negative 20. Or you could remember the rule that when the signs are the same, we add the numbers and then give it the sign of the problem, which is negative, because I have a negative 17 and a negative 3. Let's do one more. In this situation, we're going to add 3 to both sides. And we get x over here because x minus 3 plus 3 is just x. And here we're starting at negative 17 and we're going to the right 3 units, which gives us the number 14. And we know because 17 is the larger number in absolute value that that number is going to have to be negative. Another way to remember it is when our signs are different, we subtract and we give it the sign of the larger absolute valued number. So you can do it either way with your number line or by remembering the rules. And I would suggest you use the number line as long as you need to until the rules become kind of automatic, and that will happen eventually. So stop the video, practice the worksheet, review the video if you need to, and ask good questions.